If you've ever thought, wait, do I flip it, multiply, find a least common denominator? This is for you. Today we're going to learn all about fractions. Whether it's adding, subtracting, multiplying, or dividing, this video is just for you. My name is Jennifer. This is Math Meets Paint. Let's get started. Okay, so what we're going to do first is we're going to start with adding and subtracting fractions. One key factor when it comes to adding and subtracting fractions is that they must have the same or like denominator. You need to, if they don't already have the same denominator, you're going to need to manipulate one or both of the fractions, and we'll talk about that later. But I am going to minimize my screen here and bring you to the whiteboard, and we're going to do a few fractions that have like denominators. And first we'll talk about adding fractions with like denominators. Okay, so I'm going to go ahead and write a fraction here. Let's do 2/5 plus 4/5, for example. Okay, and we can see here, and I'll highlight it just to make sure that all of our terminology is the same. The 5 in both of the fractions is the denominator, okay? The number on the bottom of a fraction we call the denominator. Because they are both 5, we can add these fractions without issue. And what that means is that we look at the numerator, add them, okay? 2 plus 4 in this example is 6. And then because they have the same denominator, we just keep that. So 2/5 plus 4/5 is 6/5. And it's that simple when you have a like denominator. If, however, you're subtracting, let's look at a subtraction problem. 5/4 minus 3/4. Okay, we have a denominator of 4 in both of these fractions, okay? Which means we can subtract the numerators. 5 minus 3 is 2, and keep or retain the denominator, which is 4, okay? So you've just added and subtracted fractions that have like or common denominators, okay? Let me give you another example, okay, just to give you one to practice on. And I will give you a second to pause the screen if you need to. Okay, we have a like denominator here with 10. So we are going to look at our numerators, which is 9 and 5 in this problem, and add them, okay? Because this is an addition of two fractions with like denominators. And 9 plus 5 is 14. And then we keep the denominator, which again is 10. All right? If we were to use the same two fractions, 9/10 and subtract 5/10, we would again acknowledge that the denominators are the same and then just subtract the numerators. 9 minus 5 is 4. And then again, because they are like or alike, we would keep the 10. Now, the one thing I do want to point out is as you get into your high school years of math and perhaps middle school, your teachers may want you to simplify fractions. I will do another lesson solely on simplifying fractions. But if that's the case, then we have what's called an improper fraction here in 14/10 because the numerator is larger than the denominator. And so we would need to simplify that, which we'll go into in another lesson. For now, I will go ahead and simplify it, okay, for all of us. for those of us that might want a simplified mixed number. Okay? Very good. So now, let's move into talking about fractions that do not have the same or like denominators. I'm going to write an example, okay? And I'm going to do the same thing. I'll do a subtraction problem and an addition problem, both with unlike denominators for you. I'm going to start with a whole number, and I'm going to subtract a fraction. And I'm doing this for a few reasons. Typically, if you're learning about fractions, you may remember that any whole number is itself over 1. So I'm going to go ahead. I don't want you to get a little confused or thrown off if you see a whole number minus a fraction, because any whole number can be put over 1. Any whole number is itself over 1. Okay? So now we have a fraction minus a fraction. And if we see here, we see that the denominators are not the same. Okay? So I am going to rewrite this problem, and I'm going to rewrite it vertically. Okay? One problem, one fraction that is, over the other. Okay? So if you recall, we have 6 wholes minus 1/6. So the 6th, as you saw, I put over 1, because again, any number is itself over 1, and 1/6 remained 1/6. But we see with our highlighted circles here that 1 and 6 are not the same. So we have to take a different approach when we go to subtract these two fractions. Okay? We need to, I'm going to go ahead and circle them down here so we know what we're doing and why we're doing it. We are going to create two fractions that have two fractions that have the same denominator. So as I'm looking at 1 and 6, I need to be thinking of one key number, and that is the least common denominator. That'll be something that we'll refer to over and over again as it comes to adding and subtracting fractions that have unlike denominators. You want to get what's called the least common denominator. Now, you can get a common denominator, but it's not going to give you a final answer. It's going to give you an answer that you'll need to simplify. So the least common denominator is always most beneficial. So when we look at 1 and 6, and if that's a concept that we will want to revisit in the future, I'm happy to do that. But let's look at 1 and 6. 1 and 6, when it comes to the least common denominator, the smallest number that both 1 and 6 can go into is 6. 1 goes into 6 times, and 6 goes into 6 1 time. So when we go to put our least common denominator, we are going to create equivalent fractions for both of those fractions, creating an equivalent fraction that has that like common denominator or least common denominator on the bottom. Okay? Now, once we create an equivalent fraction, we're going to see that nothing needs to be changed in the bottom fraction. 1/6 will remain 1/6. Okay? In other words, what did we do to go from 6 to 6? We just multiplied it by 1. Okay? And when creating an equivalent fraction, whatever you do to the bottom, you must also do to the top. So if we multiplied the bottom by 1, we're going to have to multiply the top by 1. And that's just going to get the same value, 1/6 in this case. Now, the top fraction, we have to ask ourselves, what did we do in the top fraction, 6 over 1, to get an equivalent fraction with 6 as a denominator? Well, we would have to multiply 1 by 6 to get 6 as a denominator. And if we did that to the denominator, we would have to do the same thing to the numerator, okay? And once we do that, 6 times 6 is 36, okay? Now, you may also look at it like you just multiplied the top fraction by 6 over 6, which is just 1, okay? Any number over itself, for example, 6 over 6, is just 1. If we did the bottom fraction, 1 over 1 is just 1. Any number over itself is 1, okay? We talked up here about any number over 1, any number is itself over 1, which is true. But here, below, any number over itself equals 1, okay? And this is back to, what you learned about fractions in the beginning. Any number divided by itself is 1, okay? A fraction is a division problem, okay? So now back to our subtracting fraction with unlike denominator example. We've got 36 sixths, okay? We've got 36 sixths minus 1/6. Okay, so this is our new problem. And remember, this is a subtraction problem. Okay, 36 sixths. Remember, we go back up to when we had like denominators at this point because we have like denominators in 36 sixths and 1/6. So we can now just subtract the numerators and retain or keep the denominators. So 36 minus 1 is 35, and 6 is kept, okay? Now, if you wanted to, again, go ahead and simplify the improper fraction to a mixed number, you're going to divide 35 by 6. 6 is going to go into 35 5 whole times with a remainder of 5. And we will put that over the denominator, okay? This is another skill that if we need to revisit in the future, I'd be happy to do. Okay, let's continue to move on. I am going to do another example of subtracting with an unlike denominator adding with an unlike denominator, and then we'll move on to multiplying and dividing. Okay, so let's look at a final addition problem. And again, this one has unlike denominators. So I've got 7/8 here plus 3/4. Okay. And you can see how I set these up off top. I know that I have unlike denominators, 8 and 4, and I know I need to set up two equivalent fractions, okay? These two equivalent fractions are going to need a least common denominator. Now, I'm going to go ahead and circle our two unlike denominators, okay? And remember, we need to create a least common denominator for these two fractions. And we're looking at 8 and 4. And we're thinking of the smallest number that both can go into. So I know 4 goes into 8, and I know 8 goes into 8. So let us put the least common denominator, 8, in both of these places. So we now will have a common denominator that will allow us to add the fractions, okay? Now, I'm going to go ahead and get rid of these bubbles, okay? And create an equivalent fraction. Now, Are we going to have to do anything to the 7/8 in this case? No, because there's nothing about the denominator that we had to change. So there's nothing about the first fraction, 7/8, that's going to have to change. In effect, we're multiplying the denominator by 1. We would do the same thing with the numerator, okay? I need to figure out how to get these red boxes off. I don't know why they keep popping up, okay? For the bottom fraction, we are going to multiply both the numerator and the denominator by 2, okay? 4 times 2 is 8, okay? And 3 times 2 is 6. So now, as you guys can recognize, we have the same denominator here in 8. So now we can focus on the numerator, adding the numerator, 7 plus 6, which is 13. And then we know that when the denominators are the same, we just keep it. Okay? So 13/8 is our final answer. It's an improper fraction, so I'm reluctant to say final answer. It is our improper fraction answer. If we'd like to create a mixed number, we would simplify it to 1 and 5/8. Okay? Very good. Now, we are going, and if you have any questions, please leave them in the comments below. Okay? We're going to move on to multiplying and dividing fractions now. And let us switch colors. Okay, so now when it comes to multiplying and dividing fractions, and I will make these notes a PDF and attach them below the video so that you will have the note version of this, if I can figure that out, okay? Then I will share that with you as well. Okay, so now let's talk about multiplying and dividing. When multiplying and dividing fractions, you do not need to worry about the common denominator issue like you do when adding and subtracting. Okay, again, when adding and subtracting fractions, they must have the same denominator. Okay, so as we just learned, if they don't, then you've got to create a like denominator before you can add or subtract. Okay, when multiplying fractions or dividing fractions, that's not necessary. That you have a least common denominator is not required. Okay, so we're going to look at a few multiplication problems and a few division problems, and then I've got a tip for you at the end, so please stay tuned. Okay, first, let's start with a basic multiplication problem, okay? I'm going to start with 5/4 times 1/3, okay? And what you need to know about fractions, multiplying fractions, is that when multiplying, you're multiplying straight across, okay? So if you can remember that it's straight across, then that's the key. That's what you need to know when it comes to multiplying fractions. Okay, when we get to division, it's a little different, and we'll talk about it when we get there. But when multiplying fractions, you're multiplying the numerator times the numerator and the denominator times the denominator. Okay, so in this case, we have 5/4 times 1/3. 5 times 1 is 5. And 4 times 3 is 12. So we have a final answer of 5/12. Okay? This cannot be simplified. 5 is a prime number and cannot be simplified, so this would be a final answer. Okay? Let's now look at another example. Let's look at a whole number. Okay, we talked about a whole number in our last adding and subtracting problem, or one of our last adding and subtracting problems, where we talked about whole numbers being themselves over 1, okay? So if I have this problem, for example, -2 times 3/7, we can rewrite that to be -2 over 1. And don't let this negative throw you off here. We'll get into rational, irrational numbers later on. For now, know that a negative times a positive is a negative, okay? So we've got -2, which is -2 over 1, and we're going to multiply that times 3/7. Okay? I'm going to use our red arrows again. And you'll want to do that until you've mastered multiplying fractions, because it's not something you want to forget. But once you realize that you're just multiplying numerator times numerator over the denominator times denominator, you're going to be good to go. Okay? Now, a negative times a positive is a negative. So -2 times +3 is a -6. And a +1 times a +7 is a +7. 1 times 7 is 7. And then we have a final answer in -6/7. Okay? So just to reiterate, we have a few things to remember. When multiplying fractions, you're multiplying straight across. And if you have a whole number, as in -2 here, it's itself over 1, okay? That is true for any whole number. You can always put it over 1 and create a fraction from it, okay? All right, so let's look at a division problem now. And I always like to tell my students, if you know how to multiply, you know how to divide, because there's one difference when multiplying. Let us look at 1/2 divided by 5/4. 1/2 divided by 5/4. We see, again, the unlike denominators are irrelevant. We don't need to have the same denominator in two fractions that we are either multiplying or dividing. Again, that is only relevant and only a rule when it comes to adding and subtracting fractions. When multiplying or dividing, you do not need to have the same denominator. Now, what is different when dividing is we use an acronym to describe the what you do in this case, keep, change, flip. But I know that there's more to the understanding dividing of the division of fractions, so which I can go into in the future. But what I'd like to do right now is just explain the steps that we take. I've already explained that there's no need to have a like denominator, but what you are going to do is you are going to affect the division sign and reciprocate or flip the second fraction. So if we rewrite the first fraction, okay, which is what the first step is, it's to rewrite the first fraction, okay, and then we are going to change the division sign into a multiplication sign, okay? And then we are going to reciprocate or flip the second fraction. So instead of 5/4, we are going to have 4/5, okay? So again, what's changed here is the division sign becomes a multiplication sign, and the second fraction is flipped, or we take the reciprocal of the second fraction. Not the first fraction, but the second fraction. And you cannot you cannot do it differently. You can't start or change what you're starting with. You are dividing 1/2 by 5/4. You're not doing the opposite, okay? So make sure to keep that first fraction the same. Change your division sign to a multiplication sign, and then reciprocate or flip the second fraction. And now, like I said, now that you know how to multiply, once you've done those first 2 steps, you know that it's just multiplying across from here on out. So 1 times 4 is 4, and 2 times 5 is 10. Now that can be further simplified because they're both even. Okay, if we divided both by 2, okay, we've got this box keeps happening. If we divided both by 2, we would be able to further simplify this problem into 2/5, and that would be our final answer. Okay? I hope this is making some sense, and please reach out if you have any questions or would like me to do more examples. I would love to do that for you. So, as promised, we're going to finish up today's Math Monday by showing a special strategy that I know a lot of my 8th grade students have requested in the past, and I think my daughter included, and I think would be very helpful. So this is a strategy that is very helpful when it comes to multiplying or dividing with very large numbers. Or if you're multiplying or dividing multiple fractions. So still a strategy for fractions. I'm just going to show you a couple examples. And again, it's a topic that we can explore further in the future. Let's look at 3/10 divided by 2/5. Okay? We're going to put in practice what we've already learned, and that is going to be to change the division sign to a multiplication sign, and then reciprocate or flip the second fraction. Okay? And we do this. In doing this, we get our multiplication problem, okay? Now, the strategy that I'm here to show you and others is to cross-cancel. Cross-canceling is a math strategy that a lot of us use to, what I like to say, simplify before you multiply. And what that means is if I were to multiply this fraction, as we've been taught, straight across, you've got 3 times 5, which is 15, and 10 times 2, which is 20. And this can be simplified. We can simplify this by dividing by what we call the greatest common factor, and the largest number that goes into both of these is 5. And if we, I'm not sure about that box. Okay, if we divide both of these by the greatest common factor, you're going to get a simplified fraction of 3/4. Now, I'm going to show you a trick. I'm going to go ahead and rewrite the problem and show you that if you cross-cancel, you're going to end up not having to simplify in this stage, okay? And when cross-canceling, what you do is you take a factor, okay? A factor is a number, okay? From your set of numerators, and a factor or one of the numbers from your set of denominators. Now, these can be vertical, right on top of one another, or diagonal, as long as there's one factor from the top and one factor from the bottom, and you can simplify or cross cancel. So if we look here at 5, you've got a 5 here and a 10 here. And they are both multiples of 10. 5 goes into 10 and 10 goes into 10. So I can ask myself, how many times does 5 go into 10? And it goes into 10 one time. So I'm going to put a 1 there and ask myself how many times 5 goes into 10. And 5 goes into 10 2 times. So I'm going to put a 2 there. Now, there's nothing else that we can simplify. 3 and 2 don't share any common factor, and neither does the 1. Okay? So now we can multiply our new set of factors. 3 times 1 is 3. 2 times 2 is 4. And we end up with our final answer without having to simplify. Okay? Let's do one more example. Okay, in this example, I am going to use 3 fractions. I want to show you that you can use more than one fraction when you're multiplying. And if you've got multiple operations in there, you wouldn't want to use this. But if you have several fractions that you're multiplying together, this is okay to do. Okay, let's look at 2/9 times 3/8 times 9/15. Now, if we were going to, we would approach this the same way we would approach any multiplication, any fraction multiplication problem, and that is multiply straight across. So we would multiply 2 times 3 times 9. I've got my handy dandy calculator here, which I don't necessarily need for the numerator, but I will need it for the denominator when we get there, because we have 9, 8, and 15. Okay, so 2 times 3 is 6, and 9 times 6 is 54. Okay, and then I just turned my calculator on. Let's multiply 9 times 8 times 15. Okay, we've got 1,080. Okay, and when you get a high number like that, and you don't necessarily need 3 fractions to get such a high product, but you're going to have to simplify that eventually, and we don't always want to do that. So if we, okay, and I'm just going to do the cross canceling on the same problem so that we can all can see it ending up with the simplified fraction. Remember, when cross canceling, as long as we take a factor from the numerators and a factor from the denominators, you can cross cancel or simplify. Okay, so I am looking at what I have here, and I have a 2 on the set of numerators and an 8 on the set of denominators. So those two can be cross-canceled. Okay, I am going to divide both by 2 and see what I get. 2 into 2 is 1, and 2 into 8 goes 4 times. Now, let's use a different color, how about blue, and talk about the 3 and the 15, okay? The 3 and the 15 can also be simplified. 3 goes into 3 1 time, and 3 goes into 15 5 times, okay? Now, I'm looking at what's left, and I see 2 9s. So let's look at those 9s. We talked about this earlier, that any number over itself is just 1. So 9 over 9 is 1. Okay, 9 goes into 9 once, and 9 goes into the other 9 once, right? Okay, so now we have new factors to multiply straight across. We've got 1 times 1 times 1, which is just 1, and 1 times 4 times 5, which is 20. Okay? Oops, I think I made the equal sign my fraction. Okay? So, what you see in cross-canceling allows us to do, if we were to further simplify 54 over 1080, it would be 1/20. So, as you're looking at that, as you're looking at the skill of cross-canceling, you can see how beneficial it would be when you're dealing with larger numbers. It doesn't take a lot on the front end of the problem. We can easily simplify 2/8 or 3/15 or 9/9 and get smaller factors that we then multiply to get a final product. Okay? And not have to worry about simplifying in the end. So I hope that strategy was a little cherry on top for those of you that may not have known it. Okay, so just to recap, you learned how to add, subtract, multiply, and divide. And it's my hope that this was a little bit of a review for those of you getting ready to go back to school in a few weeks, or for a parent who has a child that's getting ready to go back to school in a few weeks. I hope you enjoyed this video, and please like the video. Comment if you liked it, or if you'd like additional videos on my channel. I will be here on Wednesday for Watercolor Wednesday, and that's your time to watch me learn. Okay? So I hope you'll be here for that. Until then, have a good night.